So now that we've encountered trig functions, let's actually use them in a problem. Let's use them to find missing sides of a triangle, of a right triangle. So say that this is right triangle. Say this angle is 25 degrees, and say that this side is 5. Now, what if we want to find this side? Well, we can do, well, let's label our side. This is the opposite side. This is the adjacent side. This is the hypotenuse. So, katoa, we have the opposite side, so we want to narrow it down to sine or cosine, or no, sine or tangent, because those are the ones that deal with the opposite side. And we want to find the adjacent side, so not sine, but tangent. Here, tangent, opposite, adjacent, those are the two relevant sides here. So let's set up an equation. Tangent of 25 degrees equals opposite 5 divided by adjacent x. So we can solve for x here. Do like x 10, 25 degrees equals 5, then x equals 5 divided by 10, 25 degrees. And then we can evaluate this. Let's do it here. So 5 divided by 10, 25 degrees. Yeah, I'll just show you the answer. 10.72. Alright, so x is about 10.72. That's just an approximation. It's not exact, but it's rounded to the nearest hundredth place. So let's erase x here and write in 10.72. Now, what if we wanted to find the hypotenuse of this triangle? Well, we could do Pythagorean theorem because this is a right triangle and we know it's 2 legs. So we could do that. Why don't we use that to check our answer, though? Let's do it with trig first, and then we'll use it to check our answer. So at this point, we have 2 options here. Well, we want to find the hypotenuse. Let's call it h. And now we want to use either sine or cosine to find the hypotenuse. Since we know both sides, we could really use either one. I think let's stick with using the opposite side, though, just because this adjacent side is an approximation, so we might be like 0.01 off in our final answer if we use this approximation, because this approximation is also rounded. Let's use our opposite side. So let's say sine of 25 degrees equals our opposite side, 5, over our hypotenuse. We'll solve this the same way and get h equals 5 over sine 25 degrees. And let's evaluate that. 5 over sine 25 degrees, so 11.83. So h equals 11.83. Now let's check this using the Pythagorean theorem. So we know that h squared is equal to 5 squared plus 10.72 squared. So let's do 5 squared plus 10.72 squared. We get 139.92. So let's say h equals the square root of 139.92. Let's plug that in. Square root of all that stuff. 11.83. And And yeah, it matches up either way we do it. Yeah, there we go. We use trig to find the missing side of a triangle.